Here we reach the site tinkercad.com, and here is the particular circuit that which we are going to use in this particular project. So let me explain you first this circuit. This is the Arduino board, that is Arduino Uno 3, and we are using three 7 segments displays, namely this is one, second, and the third one. Now in this project we are also using these two ICs, that is CD4511. These two ICs we are using to minimize the usage of different pins in Arduino, because if we don't use these two ICs, then there would be 8 pins of this LED, 8 pins of this LED, and 8 pins of this LED. Means total 8 is 24 pins would be there, but this many pins we do not have in our Arduino. So that's why we are using these two ICs, CD4511, and I am also going to share you about how these ICs work and what are its internal construction in coming slides. So let us first understand the connection of this circuit. So the first, as we know that our temperature would range from -40 degrees Celsius to 125 degrees Celsius. So in this particular LED we have to only display minus sign or the +1 sign, because the first digit of the temperature range would be either in minus or in it would be first digit. Now in these two LEDs, namely this one, second one, and third one, we have to display different numbers ranging from 1 to 9 or anything like that. So first of all we connect all three LEDs through resistors, this one, and connect all the terminals of these three 7 segment displays to ground. Here is the ground, and we have to use all three 7 segment displays in the cathode configuration, this one also, this one, and this one. Now the above connections I think you might have understood. Now as we have to display only minus and 1 in this LED, so we are connecting only 3 terminals of 7 segment LED to different digital pins of Arduino. As we know that if you want to display 1, then we have to turn on this segment of LED and this one segment, that is namely B and C. So we connect B terminal over here and C to here, and if you want to display minus sign, so we connect this is the G segment of the LED 7 segment display, and we connect G segment to 4 digital pin. Now here we complete the connection of first LED 7 segment display. Now the second, these two 7 segment display have the similar connection, so let me explain one of it. So in this 7 segment display, first of all here we have to connect a terminal, each terminal, consecutive terminal, to the terminal of this IC. So if we have the A terminal over here of 7 segment display, we also have to connect this A terminal to the A terminal of this IC. See, you can see A and A. Then we have to connect to B, C to C, and in the similar way we have to connect all 8 pins to this IC. Now what happens, this LT pin, as you can see, LT and VA, this has to be internally short. Now why this has to be short, that I am going to show you. See, you can see this is CD4511 7 segment driver IC, and in this we have seen that blanking test and LM test, these two has to be connected. As you can also refer to my previous video, in that video also I told about you that these two pins has to be connected internally, and this has to be connected to the VCC. So this is how we are going to implement in our circuit also. See, these two pins we have connected, and this pin we have to connect directly to VCC. You can see here VCC, and in the similar way we do it in the second IC also. Now this VCC has to be connected to 5 volt. See, you can see it is connected to 5 volt. Okay. Now we the LE the LE and the ground terminal has to be internally sorted. This also I would show you. See, this ground and stores, these two pin has to be connected internally, and ultimately has to be connected to the ground terminal of the Arduino. So let us implement that also. So LE and ground terminal we have connected to ground of the Arduino, as you could clearly see. Now in this particular IC, now we are left with 4 pins, that is namely AIN, that is in, A in, BIN means a B in, then C in and D in. Now what we will do is that we are connecting A in to one of the digital pin, namely that is 9th one. The similar way, second also we are going to connect like this B1 is connected to 8. In the similar way we have to connect all 4 over here, and in the same way these 4 terminals has also to be connected in the digital pins of Arduino. You can see from the color code of this particular IC, all the 4 terminals are connected to digital pins using this purple color, while on the second side I have used pink color to differentiate between them. So here now what is we have to going to sense, that is temperature, and for this we are using TMP36 sensor. You can see if you clearly see this sensor is having 3 terminals. First terminal is VS, that is it has to be provided with the voltage source, so we have connected this to 5 volt supply. The second terminal is to that whatever the data that the temperature sensor reads or fetches or the senses has to be read by this analog pin, and I have told in previous videos also that sensors are used for in analog pins. So we connect V output, as we have to read the data sensed by the TMP36, so we connect it to A0. And the last terminal, that is you can clearly see its ground terminal, has to be connected to the ground of the Arduino board. So here we end our circuit. Now we go on the part of coding. Okay, now we are going to see the datasheet of TMP36. Let me show you. From this TMP36 you could see the working. Now let me tell you one thing, that TMP36 is a temperature sensor. It will be working from minus 2.7 volt to 5.5 volt only, and it will won't work for a big amount of voltage. And this is the particular site from which you can see the features and benefits of using this temperature sensor. You can see all the data sheets of the particular sensor, design resources, and see what I told you, that is it works at lower voltages, that is 2.7 to 5.5 volt, and accuracy. Now talking about the accuracy of this sensor, it may vary from plus or minus 2 degrees Celsius. And this the low self-heating means it won't heat to exceed, means it won't burn when it is operated under this amount of voltage. I am also going to share this link in the coming slides. Okay, now going on the part of coding. So let's code this circuit. So here we go. I have already written the full code. Now I am going to explain this code. So first of all, we have taken 2 variables, namely temp value and temp value MV. The temp value variable we have used because we are going to fetch data from the temperature sensor, and another variable we have used because we are going to convert the temp value, because it is going to read in the analog pin, so the output will vary from 0 to 1023. So we have to convert this into 0 to 5000 millivolt. And you might be questioning that why we have used float, because as our readings would be in decimal points, we are going to use float variable, float as a data type. Now the second variable is integer. Now we have used these variables S2A, S2B, S2C, S2D, namely because we are here S2 means 7 segment, 2 represents this one second segment 7 segment LED, sorry, display, and there, as you know that this 7 segment display is connected to a particular IC, and this IC is having only 4 digital pins that has to be connected with the Arduino. So we have only 4 variables, that is A, B, this one B, C and D for the 7 segment display of second 7 segment display. Now similarly for third 7 segment display we do the same thing till D. Now for the first 7 segment display, as we know that we have to only display either minus or plus 1. Okay, so we are going, because to represent 1 we have to connect B and C. So we have given C to 3 digital pin and B to second digital pin, and for to represent minus sign or to display minus sign we have to connect G segment of the display. So we are given G segment to the fourth digital pin. Now as you know that whatever value we are that the temperature is going to sense, it would be comprising of either 2 digit or 3 digit. So maximum there would be 3 digit. So we are taking these 3 variables, and this one is the temperature value in degree Celsius, because first we have already got a temperature value and then we have converted into millivolt. Now we have to convert in degree Celsius, and this degree Celsius we are going to divide into 3 parts, that is ones place, second place and the third place. So these 3 variables we have used, and these 3 variables that is namely I, J and K is used for the looping purposes. So one more thing, that we have to take this whole 2-dimensional array. Now what is the use of this 2-dimensional array? First of all, this array is comprising of 16 elements, and each element is having 4 elements in them. You can see this 1, 2, 3 and 4, and 4 lines, in total would be 16, and each element is having comprising of 4 different elements in them. Let me clear you one thing, that these 16 variables or elements are representing 0 to 15 by 15 digits in binary codes. You can see 40 means 1, 0001 that is meaning 1, it is the binary code of 1, this is the binary code of 2, etc, etc, and the last one is the binary code of 15. Now in before videos I also told you that compulsory we need to use 2 functions for Arduino, that is void setup, and the second function is void loop. So in void setup, what we are going to do in void setup function? So first of all we are going to sense or the get reading from the temperature sensor, that is TMP36, and this would be read in A0, analog pin A0. So first of all we are pin mode, that is the command we are going to use to initialize A0 pin, that is analog 0, and we are going to get the output or the fetch output that we are going to use in our circuit. That's why we write over here input instead of output. Now we want to use the serial monitor. You can see at the bottom. So we have to write as a syntax purpose serial.begin, so it would initialize the serial monitor. Now to initialize or to pin mode to all other pins is from all other pins we are going to get output in some other way, means all the pins are connected to 7 segment display through different ICs. So from 0 to 14 all the pins we have connected from I, and we have written over here output. Here the I will vary from 0 to 13, it won't be 14 because the I is less than 14, not equal to 14. Now initially for this 7 segment display we have already given these 3 pins as low, because before it would be in the off condition. Now for the clear purpose, all the pins we have taken in the low state, means in the off state, so initially we won't be getting any output at the starting of the simulation. Now we go on to the looping part, that is void loop function. Now the first thing is that at A0 whatever the value that the temperature senses would be stored in temp value variable. This is the variable. Now we have to convert this temp value into millivolt. So this is the formula that we have used. This temp MV means it will be converted into millivolt. That is temp value into 5000 divided by 1024. Because we know that only temp value would vary from 0 to 1023, but we have to convert into the 0 to 5000 millivolt. That's why we are going to use this formula. Now once we get the temperature in millivolt, we have to convert this temperature value into the degrees Celsius. So we use this formula, that is dividing the millivolt by 10 and adding -50 to it. So we are going to get temperature in degrees Celsius. Now the main part comes is the conditions. So first of all, we have kept two conditions. If this condition satisfies, that is if the temperature value is greater than or equal to 0, and the if the temperature is greater than or equal to 0, this condition would be executed, else this condition would be executed. Now I am going to explain how this works. So if the temperature is greater than 0, means it would be comprising of the 2 or 3 digits. So first of all, the third digit means the last digit of the number. We will get how we will get. So temperature that is in degrees Celsius has to be modulus. We have to use this function modulus. Why we use this modulus symbol? Because we will get the remainder when the temperature will be divided by 10. The remainder would be the last digit of the temperature. So this is how we get the last digit. Now to get the second digit, we first of all divide the temperature divide by 10. So we will get in 2 digit numbers, and then we use this modulus 10. So this is how we will get second digit, and in the similar way, if we divide by 100, we will get the first digit. Now one more thing, if the temperature is greater than or equal to 100, then this is the first one, that is the first 7-second display has to be executed in such a manner, because in the first 7-second display we have to only display 1 if the temperature is greater than 0. So we are using B high and C high, but G as low, so it would represent display 1. Now what about these two displays? So here is code for that. For S2A means the second 7-segment display. This one is for 7-second. So we are going to use this here before that we already used. Now for example, we are getting 124 as the temperature. So we have got the second digit. The second digit is, you can say, 2. Now this line would go to the second digit, means second element of this array, that is 1. This one is 1, 2, sorry 0, this one is 1, and this one is 2. Now from this line, the first element, that is it will go to this one, and now the third element of this whole element is that 0, 1, 2 and 3 means 0. So now S2A means the A segment will be 2,3 means it would be in the 0 state, means it would be in the off state. In similar manner, this would be also in the second element, means this is the whole element, that is the second, because this one is 0, 1 and 2. Now the second element of this particular whole element is this one is 0, 1 and 2. Now you can see this one is 1, as here it would be 1, so here also it has to be 1, so it would be in the on state. So in the similar way, we are going to get we are going to manage all 4 pins, all 4 terminals of this particular IC to give the input to this digital pins, to this 7-segment display, so to display that particular number. And in the similar way, we are also going to get the third third 7 segment display by using this array. Yeah, for example, if we are getting third element as 124, that one is 4. 4 would be the last third digit, and so should go to the 0, 1, 2, 3 and 4. And then this 3210 means it would execute last element, then this one, and this one. So means if you want to display for this binary code for that one, means this is the binary code for 4, that is fourth digit, so you display 4. This is how if this condition would be executed in the same way to display the temperature. Now what happens in else condition, that we are going to see. This one, this full is the else condition. So the temp value would be as bar. So first of all, we initialize temp value in degree Celsius to minus. For whatever value we have got, we have to reduce from that. Now if in the similar way, whatever we have done in if condition, the same way we have to do in else condition. But the different thing in this else condition is that once we get temperature less than 0, so first LED would be 0, means it won't be displayed anything. It would be 0, either it would display minus or nothing. So we know that it would display minus if it is less than 0. So we have to do B and C has to be in the lower state, while G, because G has to be in the higher state to display minus. So we have written this. Now display whatever I explained for this logic, the same logic applies over here, same to same. Now no difference in them. This is also in second and third digit. This is also for second and third digit, because it is going to display in second and third 7 segment display. Now as we want to display all the digits, all the values that is going to be executed in the whole program, we use this serial monitor to see all the elements that also I am going to see. First one is serial.print temp value C, means whatever value we are going to get as of temperature, that we are going to display in serial monitor. Then this one is for space, means it would print space so that more clarity is there. Then this would display first digit, second digit, third digit in a similar way. Yeah. And this one it would display the binary code, means if the first digit is for example 1, then this whole code would represent the binary code of that digit. Then space, then again the second digit. Now this code would display second digit, binary code of this second digit, and this binary code would come from this array that we have already mentioned or declared. And similar applies to the third. And the last we are going to use delay function, because we are using 3 seconds delay. Here it is 3000, that means 3000 millivolt, that means 3 seconds. 3 seconds delay we are going to use, so it would be pause for 3 seconds. Again the particular loop will continue and run multiple times. So let us start the simulation. So here we go. See, right now we are getting the values as 24, as this one represents the temperature value. Then the first digit, as you know that first digit for 24 would be 0, then second digit is 2, third digit is 4, and similar way these three would be binary codes for them, you can see. So first 0 is there, then 0 is, this one is the binary code for 0, this one is the binary code for 2, and the last one, this is the binary code for 4. And similarly it is executed. Now let us see the 7 segment display, what is the variation in them. So let us see. We change the slider, so we go in this part. So we are getting 121 as a temperature. Now we on the negative, see, you can see clearly the first 7 segment display is displaying right now 1, because it is greater than 0. Now we go on the negative side. So here See, you can see minus 40 degrees Celsius. This is how we do this circuit and run this. So here I stop the simulation.